Hi everyone, welcome back to Cody's Lab. So today I'm actually going to be taking the lens off my camera, replacing the lens with a solid disc of metal. In this case, a US $1 coin. This is going to form an Aragoscope, basically a telescope that does not use lenses or mirrors. So the first thing I've done is I've taped a piece of wire to the coin. Just like that, making sure not to get any pieces of tape hanging over the edge, because I want this to be a perfectly smooth circle. The wire coming off is actually going to cause issues, but just having it in one place is not going to ruin the thing. Next thing I need is something to look at, and so I'm going to use this bright flashlight, which I'm setting on top of that post, and now I'm going to walk across this field. Now that I'm on the far side of the field, I'm far enough away that that light now approximates a point source. And so I'm going to attach this coin to this post right here. Now all I've got to do is travel back about 20 feet and line that light up with the coin. So this is with the lens on, and from this vantage point, as I move the camera into the shadow of the coin, you can see the light does not completely go away. In fact, it looks like there's still a slightly dimmer light there. Move it out, you get the full brightness of the light. Move it back in, you get something. Now let's take a picture without the lens on the camera. So this is what the camera sees, and as I bring it into the shadow of the coin, you can see there's a bright spot in the middle of the shadow. This is in fact an Aragoscope spot. What you're seeing here is proof that photons do not travel like bullets. They travel sort of in waves, and waves can curve around the edges of an object. And if you put a detector at the right spot, those waves converge together and create an image. In fact, what you're seeing here is an image of the lens of the light. So you're seeing the light source here, magnified quite a lot. You can also see the wire holding the coin and the distortion that it's causing. It's not too bad. Now to prove it, let's actually go add something to the light to make it a little bit more recognizable of a shape. Let's just try a couple of pieces of tape in a cross pattern. There's a lot less light coming through now, mostly because the flashlight's battery is going dead. And so I wasn't able to film it at 30 frames per second. But here's a single frame, 4-second long exposure. You can clearly see that there are 4 dots where the light is coming through past the tape. So this is an image of the light source. Now let's try something a little bit more ambitious. How about a piece of foil with a bunch of holes that spell out Cody's Lab? Well, you can tell I definitely changed the shape of the image, but it's still very blurry. It's just too small and the resolution not enough to make out any of the actual dots, and certainly not enough to read the word. We can get better resolution by using a larger disc. This is essentially the same as getting a telescope with a bigger aperture. Okay, fresh battery in the light, and I've got a bigger disc here. This is a canning jar lid, wide mouth, so it's quite a bit larger than the coin. That ought to give us some better resolution. Unfortunately, it means I'm also going to have to travel farther back away from it. 98, 99, 100. In case you're wondering why I'm using feet and not the metric units, my shoes are 12 inches long. It's very convenient. So this is what I came up with. The image is pretty blurry. I think this is mostly because of the fact that I had to leave the shutter open for 30 whole seconds to gather enough light. Density variations in the atmosphere due to the wind caused the image to jitter around a bunch, and this kind of smeared it out across the sensor. Also, I probably could have been better with my focal length measurements. But the fact that you can actually read this 2-inch long word from a distance of nearly 700 feet using a metal lid as a lens is just simply astonishing. I don't even think my 6-inch telescope could manage this. So it seems that this imaging technique could indeed be used to make a telescope. Quite a powerful one, in fact. I thought about using it to actually look at stars or something, but I ran into some problems. First of all, it's a little bit cloudy, and stars have a tendency to be rotated out of view, and this thing is very hard to aim because it just magnifies it so much. City lights are kind of similar to stars, and they don't move around, so I decided to try focusing on those and see if I could magnify it. And I think I could. Just positioning my eye into the shadow, I was able to get some lights to, do the thing where they aren't blocked when you put the shadow on it. But when I put the camera on there, it, the exposure took so long, and really, if you think about it, if the city's more than 6 miles away from you, there's more air between you and them than there is between you and space. And I was having problems with the air moving around with just 700 feet. Put 9 miles between me and the object I'm looking at, and now it just moves all over the place. It's completely impossible to image. But it would definitely work in space. In fact, NASA has been looking into using this as a new space telescope, and I think it'd definitely work. You put a disc that is lightweight but really large, you get the equivalent of a telescope with a really large aperture. So not only would it be cheap to launch, but also incredibly powerful. Anyway, after my little teaser that I put at the end of one of my videos, link in the description, many people have thought that I got this idea from a Veritasium video. I didn't, but I did go back and watch that video. Great video, he explains it very well. In fact, if you want to know more about how this works, I definitely recommend you go watch it. While you're at it, I recommend another video to watch as How Far Can Legolas See by, I think, Minute Physics. I'll put the links down in the description. I think that'd be good to watch to understand this video a little bit better. It was kind of funny. I think me and him must have read the same set of source material, except that I kind of caught the whole thing about the light source needing to be far away, not the shadow far away. Right, so he got that wrong, but yeah, anyone could do that. It is much easier to do it with lasers. It's much more forgiving because the laser light is already a plane wave. It's already all coming in phase. So it's kind of like a laser is a point source at infinity, even though the laser might be close. Seems fitting that I'm filming this video so close to Halloween. You know, out in the middle of basically nowhere, total darkness, artificial light. Earlier when I was actually filming the experiment, I was constantly checking with my light to see if I could see the eyes of coyotes. There's cougars out there too, but cougars, mountain lions, they don't scare me so much because they don't hunt in packs. The coyotes, I've seen what they do to deer. Anyway, hope you all enjoyed. I'll see you next time.